In the vast expanse of the cosmos, mysteries and misconceptions collide. Myths and misunderstandings have taken roots even in the field of astronomy as well. In the boundless tapestry of the cosmos, myths have danced among the stars for centuries. From ancient tales of celestial creatures to modern misconceptions about our solar system, these myths have clouded our understanding of the universe. This is the Universe Factory, and today we embark on a journey to dispel these astronomical fables and unveil the stunning reality that science has illuminated. Before we begin, if you are constantly curious about the space and the universe, this channel is right for you. So subscribe and press the bell icon to get notified every time we post space related content here. You may find us on social media platforms as well, links to which have been mentioned in the description. Make sure to check out. So without any further delay, join us as we shed light on the mysteries, unveil the truths, and debunk the myths that have lingered in the realm of astronomy. This is going to be a 2-part crazy series. Let's do this. Black holes are amazing, they don't suck. And I mean literally, they don't suck. Black holes have a gravitational pull so intense that not even light can escape their clutches. They drain the life out of stars, ripping away layers of gas and shredding the component atoms. However, the black holes of science fact and science fiction are not entirely alike. In reality, black holes behave almost exactly like any other massive object in the universe. Objects can actually get away from their gravitational pull safely from a safe distance with a sufficient speed. This speed required to escape the gravitational pull of an object, whether it's a planet or a black hole, is known as the escape velocity. Let's take a simple example. For an object like the Sun, with a modest gravitational pull, an object only needs to travel at a speed of 618 km per second to escape. If this speed cannot be achieved, the object will fall back down toward the solar surface. At the event horizon of a black hole, even something traveling at the speed of light, almost 300,000 km per second, would not be fast enough to escape, and the only option would be to continue inward. The further away from an object you go, the lower the escape velocity, and far from the event horizon, black holes behave just like stars. Objects passing far enough away and at a high enough speed are in no danger of being pulled into the center. And if the Sun was swapped with a black hole of the same mass today, Earth would continue to orbit as normal. So no, black holes do not suck. Human bodies are adapted to survive under the pressure of Earth's atmosphere. But when this is removed, water in the tissues start to evaporate and the body starts to swell. Human skin is flexible enough that this does not lead to an explosion. But after around 10 seconds of exposure, you may become unconscious. This had happened to an unfortunate spacesuit technician during NASA test in 1966. Some equipment failed while on the test, but thankfully the pressure was restored after just 30 seconds and the technician was recovered. So no, we would not explode in space without the spacesuit. Most people know that the Earth doesn't travel around the Sun in a perfect circle. But Earth's orbit isn't as elliptical as people imagine, and over the course of a year, the distance between Earth and the Sun varies by just 5 million kilometers. That's only about 3%. What's more, during the winter in the northern hemisphere, we are actually closer to the Sun than we are in the summer. The main reason for changing the seasons is the actual tilt of the Earth. As the year progresses, light hits the northern and southern hemispheres at proportionally different angles and for different amounts of time every day. During the winter, the days are short and the light strikes the atmosphere at a low angle, glancing through the glasses as it travels towards the surface and spreading out as it reaches the ground, distributing the energy. During the summer, the days are much longer and the sunlight hits the earth at a steep angle, taking a more direct path toward the floor and concentrating the energy into a smaller area. So, no, if you are having summer, the earth is not near the sun, but some distant people are having winter at the same time. Well, this is a bit tricky, but this is not true. Actually, spacecrafts like the International Space Station is constantly under the influence of Earth's gravity. That's what keeps them in orbit. The weightlessness that the astronauts experience is because they are falling gradually towards Earth. Gravity pulls the ISS towards the ground, but the station is moving so quickly that it shoots over the horizon, falling around the curvature of the planet instead of coming back down to Earth. Essentially, the astronauts inside are a constantly free fall. So the space does have gravity. In fact, we are bound by the sun's gravity that keeps the Earth revolving around it in precise orbit. That is not at all true. Everyone knows the basic things that fire needs to survive: fuel, heat, and oxygen. The sun has fuel as it is composed mainly of hydrogen and helium gas. Helium is an inert element, but hydrogen is highly flammable. The sun also generates an enormous amount of heat energy. Its surface is about 5500 degrees Celsius hot. But there is no oxygen in the space, so the basic things trio is incomplete for the sun. Actually, the sun isn't really a ball of fire. The heat and the light that are the products of a thermonuclear fusion that's constantly happening inside sun with high pressure. A high-speed collision between hydrogen atoms allowed the two nuclei to fuse together, forming helium. This releases tremendous amounts of huge quantities of energy as a gamma ray radiation. Here is fun fact. Every second inside the sun, 700 million tons of hydrogen smash together to form 650,000 tons of helium. This in turn triggers more fusion in a chain reaction and keeps this natural nuclear reactor going. So no, sun is not a burning fireball, it doesn't have oxygen with it. And there you have it, the first part video where we have navigated the cosmos, separating facts from fiction and shedding the light on some common astronomy myths. The truth about our universe is more fascinating than we ever imagined. Thank you for joining us in the cosmic journey. If you like this video, give it a thumbs up and share it with everyone. Subscribe to the channel, press the bell icon so we are going to post the second part of the video sooner. You don't want to miss that. Meanwhile, watch these suggested videos as well. We'll be back with yet another super interesting video for you soon. Until next time, keep gazing at the stars, reaching for the unknown, and as always, keep looking up.